Alright, our special cases, we have our perfect square trinomials on the left here. It can come through with either addition or subtraction. And then we have our difference of squares. So we've worked with factoring these, but what we can also do is multiply them out. So with the perfect square trinomials, and that's the key, is that like when I see this perfect square right here, I should be getting a trinomial at the end of that. The only time that these will simplify down to just two terms is when you have the difference of squares. When you have the same terms across the two sets of parentheses, one's positive, one's negative. That's when you end up with two terms. Because the most common mistake, and this is one of those mistakes that I see calculus students make, and it's that taking this and changing that to x squared plus 25. But what we need to get in the habit of is that little red flag should go off, because there should be three terms. We're missing a key middle term to this. Now, there's a rule listed up above here, so because it's addition, what I'm going to be doing is taking the square of the first term plus 2 times the first term times the second term, and then the third term squared. So I'm going to show you this in two different ways. But applying that formula, what we would have is, so x is essentially a, and 5 is essentially b. So we take x squared plus 2 times x times 5 plus 5 squared. And then just simplifying that down to the perfect square trinomial. What can also help with these, if this rule isn't the most memorable of rules, so if you can't memorize it, that's completely fine, because we can always get there with foiling. What I always recommend doing, and I try to do it in my work as well, is when I see this binomial squared, writing it out, that this is x plus 5 times x plus 5 can be really helpful, because then we know that we should FOIL. We need to multiply first, outer, inner, last, so that we get x squared plus 5x plus 5x plus 5 times 5. And you get to the same answer. So, you can't memorize the formula, this is the backup. At no point will I say, like, use the formula and not foiling. Nope. Either way is completely fine, and I tend to like to see this FOIL method because it's something we practice a lot more, and then it really gets at that third term coming through, in case you can't remember the formula. Anyway, so I'll show it both ways for these as well with the subtraction. If we want to apply the formula, we take our first term squared, and then because it's subtraction, you would have subtraction here, and then 2 times your first term times the last term, and then plus the last term squared. So we should be getting y squared minus 6y plus 9 with this. If we see that with foiling, we would have our two terms. We're going to do first outer, inner last. So you'd have y squared minus 3y minus 3y plus 9, which is y squared minus 6y plus 9. All right. For this one, and if we apply the rule, so what we would have, and I can even show this written out in more steps, it's that we would have 6 squared, and then it's addition, so we'd have plus 2 times 6 times 7x, and then plus 7x squared. So 6 squared is 36. We have, let's see, 6 times 7 is 42, double that for an 84. And then 7 squared is 49, and then x squared. So you can do it that way, or, again, foiling will get us to the same spot. So 6 times 6, 6 times 7, 42, so you'll have a 42x plus 42x. And then 7x times 7x for 49x squared. Alright, our difference of squares, same idea, using the formula up above here. So it's saying if you're multiplying things where you have these same terms, the only difference is addition versus subtraction, you'll take the square of the first term minus square of the second term. So applying that, what I would do is take the square of that first term of 3x, and then minus square of the second term of 1. So this would be a 9x squared minus 1. But what you can also do is just FOIL it out. If you don't want to memorize the formula, we can take 3x times 3x, which is 9x squared, 3x times positive 1 for a positive 3x, negative 1 times 3x for a minus 3x, and then negative 1 times positive 1 minus 1. So when we do this, you're going to end up with are like terms that cancel out with each other, that turn into 0. So that's where our middle term disappears, and we're just left with that first and third term. So that's multiplying with our special cases.